I would like to demonstrate my approach in the ideation and design of a fixture. This one is an 8-up for this particular part. This part is a flexible part, and it's two types of plastic. The brown one is not as flexible, but it's still bowy, and the green part is a very soft silicone type of plastic. Therefore, this part, it's not flat, but it needs to be constrained in order to measure the diameters of the hubs at several heights, and also the distance from center to center, which is a basic dimension. And this is a quick view of the print. And as you can see on the top right over here, we have different height and different diameters that need to be checked. And over here we have 7 times 9 millimeter. So from center to center, for the last one to the first one, it's 63 millimeter. Now in this case, this is going to be vision, and we are going to be able to check from the top. We can check basic dimension going across from hub to hub, and from the side we're going to be using a mirror, and we can pick up the center line and check those dimensions as well. So let's get moving here. As far as the parts are concerned, so I designed a small plate, as you can see. It looks like a lot like Swiss cheese, but again, it's needed to hold this part. The deeper pocket will hold basically a mirror post, and this small pocket will hold the part. The next part is basically a clamp that is going to be screwed on top of the main plate per se, with some slots in the bottom, will allow us to move the part in and clock it or stop it at the bottom of the slot. After that, we have a mirror post, and after that we have an end post. Then it's needed in order for the camera to see from the last mirror and not to have any distortion or not to focus outside the range of the camera. So with that said, let's go to the actual assembly here. Let me bring this up. This is the actual assembly without parts. So we have the bottom plate, then we have the top plate, which I call the retainer, and then we have the mirror blocks with the mirrors within that pocket. And we have at the end a block that will allow the camera to focus through the mirror but not go beyond this surface. In the other case, next to it, the back part of the mirror is in a sense the backstop for the camera when it focuses on the mirror. Now this fixture will allow us to basically insert or slide the part into the slot. It will stop at the end on these two surfaces, which is the same surface, therefore straightening the part and allowing us to see the part from the bottom, get the total length, get the width, and get actually the basic dimension, from hub to hub, and also look through the mirror and see the diameter of various height. Let's go take a look at the assembled fixture. And this is the assembled fixture. As you can see, the part is inserted into the slot. I'm going to quickly hide the clamp. As you can see, the part slides into the slot, stops at the end, and the clamp that is on top, it's static, it's not removable. So basically the part, it's slid into the slot all the way to the end. And now I am going to hide this last block for a moment, so you would have an idea that when the camera focuses on that mirror, the camera will be able to pick up all the diameters needed at different heights as per the requirement of the print. And let me bring that back for a second. When the camera focuses from the top, the camera can get the width in 3 different places and the length of the part in 2 different places, and also the dimension, which is 9 millimeter from center to center of each hub for a total of 63 millimeter. And that is a very basic approach of the process of taking a print and the requirement from the customer. In this case, it was the part needs to be constrained, it needs to be stopped, and we need to use a mirror to get dimensions from the side and the camera to get dimension from the top.